Hi, my name is Kenisha Correa. My student ID is DFCSDK62203. I'm going to explain about task 9.3D. Discuss the hack CPU implementation. In this task, we are focusing on design of the CPU and how this has been translated to HDL code. In this first picture, the suggest architecture of the CPU, which I will use to describe and implement the HDL code for the CPU, is represented by this diagram. Many logic gates, such as the multiplexer, ALU, A register, D register, and many more, make up the CPU. In order to quickly identify the input and output pins of the CPU, let's start this clip by hiding all of the logic gates in the figure. For the better understanding, let's first examine the general hack computer implementation before diving deeper into the CPU. According to this design, the CPU is made to read an instruction from ROM32 key, process it, and then communicate with memory as necessary. It receives inputs and outputs. The program counter records our current position within the program is in progress too. In this picture, display a detail of how a hacker computer is implemented. The primary parts are identified as follows: memory, CPU, and ROM32K. Data follow between these components as indicated by arrows. Accordingly, the CPU has a in input that is probably from memory even if it is not stated clearly. This design shows us the hack CPU's interface. The instruction memory and the data memory are the two of the three inputs that enter the CPU, as can be seen in this figure that displays the input and outputs of the CPU. The value of the chosen instruction memory is where the instruction input organizes from. However, M is the value that the CPU uses to carry out its operations and the value of the data memory register that is now selected. This is the CPU primary implementation as of right now, as the first slide shows. The CPU architecture design is shown in this picture. That explains that directive. The three main inputs are designed as reset, in M, and instruction. This architecture revolves around the ALU, which receive inputs from the A, D, and M registers. The ALU is surrounded by a number of control bits that decide how it will function in response to the decoded commands. The output consists of write M for writing data into memory, address M for memory addressing, PC for program counter updates, write M for writing data into memory, and ALU outputs. Let's move on to the code part. We can now write the CPU's code and talk about how it functions now that we have determined the input and output of the CPU architecture. In this first code, the inputs and outputs of the CPU are described in these lines. Instruction is the command to be executed, and in M is the input value for M. And reset is an indication to either carry on with the exciting problem or restart it. The M value output is denoted by output M. The location of M data memory is address M. The following instruction address is PC and write M is a flag denoted whether to write to M. The line in M indicate the chip's input pins which are in M instruction and reset. In the second code, the kind of instruction is determined by this line. An instruction is an A instruction if it's 15-bit is it's a C instruction if it's a 1. Inverts the instruction's most important bit and stores the outcome in instance. Receive the value of A instruction and puts the outcome in C instruction using NOT. In this third code, this line determines whether to increment the PC or load the A register onto the computer based on the jump section of the instruction as well as ALU's 0 and negative flags. Lead to GEQ and store the result in JLT and verifies if the third bit the instruction is 1 and the navigate flag is set. One can perform a bitwise OR operation between ZR out and NG out by using this will store the result in 0 over NG. And execute and A equal jump to A, B equal prediction, out equal PC load. Execute a bitwise and operation between jump to A and subtraction saving the outcomes in PC load. Store the result in PC and update the program counter based on A out, PC in, PC load and reset inputs.